Okay, class, the purpose of this video is just to give you the opportunity to practice several problems of simplifying radicals using both of these rules and the factoring techniques that we've talked about. Again, if you want to divide a radicand, you can do the numbers 2, 3, and 5 will typically work. So I'm just going to give a problem and then I would just pause it, see if you can work the problem, then I'll work through it, and we'll do that. We have 10 problems here that I'd like to go through. I'm not going to stop, but you should stop and see if you can work through it yourself. So here we're going to do the cubed root of 192. Now 192 is not one of those perfect cubes that I recognize. Again, the perfect cubes would be like 1 cubed would be 1, 2 cubed would be 8, 3 cubed would be 27, 4 cubed would be 64, 5 cubed is 125, 6 cubed is 216, and we'll stop there. So we know that this is somewhere in between, so I don't recognize it. So I'm going to try dividing it by 2. And when I divide it by 2, let's see, we get 192 divided by 2. That's going to go in 9 times. That's going to give me 18 and 12, and that's going to go in 6. So 96, again, not one of the numbers I recognize. So let's try dividing by 3. When I divide by 3, it's going to go in 6 times. That'll give me 18, and 3 times 12 is 64. Okay, so those are the factors I want. So we tried 2, it didn't work. It didn't give me a factor that I recognize. So we tried 3, we get 64. That is the factor that I want to do. So I'm going to have 3 right here, and 64 are my factors. Again, I'm choosing this one because 64 is a perfect cube. So I can simplify that. Remember that this radical will break down to 64 is 4 times 4 times 4, so this would be 4 cubed. Okay, this can't be simplified. This is as good as this gets, but this one I can simplify because the index and the exponent here are the same. Then this is just going to be the number 4. So this is going to be 4 cubed roots of 3. Again, I showed a couple of different techniques. If you factor down all the way, if there's 3 of a factor, then you can pull it out. So the answer here would be 4 cubed roots of 3. Next problem, you're going to want to, like I said, pause and work through each of these. Let's do a to the 7, b to the 8 over a cubed, b squared. So the square root, these are both square root. Because this looks like this right here, separated out, it's probably going to be easier if I put it all under 1. So if I were to rewrite this, n here is just 2. If there's no index, then it's just considered 2. So I'm going to rewrite this all under 1. And then say, hey, can I simplify these? Well, I can simplify these using the rules of exponents. There are 7 a's upstairs related through multiplication and 3 downstairs related through multiplication. So this is going to simplify inside of here to a to the 4th and b to the 6th. Again, 7 minus 3 is this 4, and 8 minus 2 is this 6. Well, this is the square root. So if I have pairs, then I can take them out. So in other words, if I can take and divide 4 by 2, then I would have a squared. And 6 by 2 is going to give me b cubed. Or in other words, I have 2 factors of a squared, so they can come out. And I have 3 factors, I have 2 factors of b cubed. So b cubed can come out. So the answer to this problem is a squared b cubed. want to do, let's try another one. All right. So this one has a negative on the outside. Remember with the order of operations that we are going to work the inside first. This out here just means that I basically have a -1 that I'm going to multiply by whatever I pull out. So we'll worry about that negative later. Let's figure out this 20. The 20 is not a number I recognize. So again, I'm going to start with like 2 and do 2 and 10. These aren't perfect squares. It's not divisible by 3. So if I do by 4, I get 4 and 5, and if I do by 5, I get 5 and 4, and these are the factor pairs that I'm looking for, is a 4 and a 5, because this is a perfect square. Okay, so instead of cubes here, we're looking for squares, which again, like 1 squared is 1, and 2 squared is 4, etc. 3 squared is 9, so I'm looking for one of these factors. This a is a lone a, so I'm just going to leave it. And this b to the 6th is already an even exponent, so this is as good as this one gets. Remember that I'm going to have this negative on the outside here. This 4 will factor down to 2 and 2. Since there's a pair of those, the 2 will come out. The 5 is all by itself, quarantined, so it's going to stay under. This a is all by itself, so it's going to stay under. And b to the 6th can be divided into 6 divided by 2 is b cubed. So b cubed times b cubed is 6. So this would be the final answer here of how to simplify that square root, or that radical. All right, so we're on number 4 here. Let's try doing the 4th root of 160 x to the 10th, y to the 5th, all over the 4th root of 2x squared, y squared. So again, I'm going to say, which rule should I be applying here? Well, this doesn't look like I'm trying to multiply them together. This is obviously a fraction here. So I'm going to use this rule and say, hey, it gave it to me separate. I'm going to put them together, all under 1. Let's see if we can get something simplified by doing that. So all under this radical, I have this. Well, I can take 160 and divide it by 2. That's 80. These x's are going to simplify. 10 minus 2 is going to give me x to the 8th. And 5 minus 2 is going to give me y cubed. So again, instead of there being a denominator, all of these factors canceled. So I'm just going to write this as the 4th root of 80, x to the 8th, y to the 3rd. So 80 is not a perfect 4th that I recognize. So 1 to the 4th power is 1, 2 to the 4th power is 16, 3 to the 4th power is 81, and 4 to the 4th power, I don't know, some big number. Can't think of it right now. Well, that's going to be 16 times 16, so, or 64 times 4, which is going to give you 256, excuse me, is 256. So we're looking, this is not any of those, but I have a 4 here, so I need to try to break it down to something that is. So if we start with the number 2, we get 2 and 40. Neither one of these are one of these numbers, so that's not going to work. It's not divisible by 3, so I'm going to go to the number 5. I get 5 and 16. That's my ticket. 16 is 2 to the 4th, so this is the number that I was looking for. This is already to the 4th power because it's a multiple of 4, so like 4, 8, 12. So I'm going to leave this x to the 8th as x to the 8th. This y cubed, I can't break it down any further because it's smaller than y to the 4th, so it's just going to stay y to the 4th as well. So how does this work? Well, I can't take this 5 out, so it's going to stay under. This 16 I can. When I take it out, I'm saying that there are 4 2's contained inside of the 16 related through multiplication. Because there's 4 of them, I can take out a single 2 on the outside. Okay, this x to the 8th, again, what I'm doing is I'm taking this exponent here on the x to the 8th and dividing it by 4. So 8 divided by 4 is 2. That's what is going to come out, is x squared. And this y cubed, I can't simplify any further. So this here would be the answer to this problem. Again, you should be pausing each one of these and working these problems in between. So let's see.